This is Kepler 452 and this is Tabby's star. Both the stars are of almost the same shape and type and are even at the same distance from the Earth. Yet this Tabby's star is dim here. And the interesting thing is that this change has only come in the last few years. Now, as you know, scientists mostly stay in search of dimming stars in such unnatural and unexplained conditions, because they know two main things. One, we get to know about the new and unseen events of space. And the other, according to a popular theory, if an advanced civilization is living somewhere, then such dim stars can be a proof of their identity. Because it is possible that an advanced alien civilization has covered it with a megastructure, the Dyson sphere, to suck in the energy of that star. Now, you know what's the weird part? Scientists think that the second option is absolutely right in the case of Tabby's. I mean, is it even possible for a civilization to make such a huge megastructure that can cover a star? Because the planets orbiting it in front of any star are almost as small as dust particles. In fact, if we go to make a Dyson sphere around our sun, its size will be so large that its radius will reach the orbit of our Earth. So now, the question is there any civilization that has such huge resources for such a huge structure? And if we want to make such an ultra structure in the future, then what engineering and technical difficulties will we face? Will it be possible to overcome them? Well, to make sense of all these fascinating questions, first, we have to understand how such a far-fetched idea of artificially covering a star with a man-made structure was born, and under what circumstances. Because, look, 600 years ago, Leonardo da Vinci, when he was a scientist, said that the first thing that he did was to make a portrait of a working helicopter. So even if there were no planes at that time, at least there were birds that he often saw flying around. But in the case of the Dyson sphere, there is nothing like that around us. And that's why I ask again, what must have been the inspiration behind this idea? And whoever came up with this idea for the first time, what did they think of keeping it in front of people? So look, by the mid-1950s, satellite batteries were usually charged on Earth. And once it was drained, it was technically disposed of the satellite, and it would become a part of the space junk or debris. But then in 1958, NASA launched the world's first satellite called Vanguard 1, which could charge its batteries into space using solar panels. Now, although this launch was not directly related to the Dyson sphere, but during this launch, NASA scientist Freeman Dyson said that there was something very strange in my mind. What if we started making a single sphere? What if human beings like these satellites first launched solar panels all around the sun, and then connected those solar panels and started making a single sphere? And then, as a third step, we started extracting energy from the sun through that sphere. Now, as we were well aware that at that time the total energy of the sun get into the surface of the Earth, only half can be directed. At that time, did the scientists understand well that only half energy of the sun can penetrate to the surface of the Earth or the surface of the planet? Only that is anything but the opposite. We had to come up with avars from which the energy could be transmitted changes, and of the same, a invade on the Earth. And so it happened. Our modern solar panels can only convert 20% of the energy into electricity. So even at current efficiency, sucking the sun from all sides could provide us with at least 5 to 10 times more energy. And what does this much energy mean? Well, with this much energy, we could give the entire Earth electricity for 1 trillion years. And this was the reason, and this was the era when this far-fetched idea was born in Freeman's mind for the first time. Now, obviously, if this idea is so beneficial, then at one point when we start to feel the energy of the sun falling on the Earth, then we might have to use this idea. And if we use it, then can it be that an advanced alien civilization is already using it? So great, that is, if a Dyson sphere or any such structure is detected around a star, then in that solar system, an advanced alien civilization can show the presence of a star. And this was the second reason that Freeman Dyson's Dyson sphere concept became a huge breakthrough of that time. And those days, finding an intelligent life form was like an obsession of the cosmologists of that time. Meaning that till now, all the countries were just shooting arrows in the darkness in search of aliens. Now, because of Freeman's idea, they got a direction. Now they had to find only one of the stars in the open universe, which was dimmer than the limit, and which stars were normally dimmer than the limit. And finally, after many years of research in 2015, NASA found a star whose brightness was less than the limit. So, can an alien civilization be created behind this? A Dyson sphere can be. Well, before that, we have to analyze this theory strongly, and we will need strong proofs and evidences. That is it practically possible to make a megastructure like the Dyson sphere? Let's say today's modern technology. If we try to make it hypothetically, then how difficult will it be for us? Well, according to Oxford University scientist Stuart Armstrong, Freeman's model is completely impractical. In fact, for many years, Armstrong was working on different solutions for how humans can colonize other places other than the Earth. Meanwhile, he also studied the design of Freeman's Dyson sphere. And then he realized that there are two major flaws in this design. First, to make a massive structure, we will need at least the mass of Jupiter, which is just the material. And if you can't even guess how much material it is, then let me remind you, the sphere you are standing on, and you can't see a clear path in one direction, 1,300 planets of the same size of the Earth can fit in a Jupiter. And the second major flaw, if by mistake, an asteroid collides with any part of this sphere, then the entire structure will fall into the sun after being disbalanced and falling into the sky. Meaning, Armstrong's analysis was a major setback for the idea of the Dyson sphere. But not completely, because he was the one who gave the way to the comeback from this setback. Instead of completely exploiting Freeman's idea, Armstrong made a new design to solve it, which could practically squeeze the sun's energy with the help of individual and separate solar panels. He named this model the Dyson swarm. Basically, according to Armstrong, instead of covering the entire sun, we can just put solar panels in a few areas and extract the sun's energy from them. According to this new structure, 1 crore solar panels will individually revolve around the sun in the form of rings. The major area of these solar panels will be covered with reflectors, and then they will direct the sunlight to the solar cells so that it generates energy, and then by converting this energy into microwave radiations, they will send it to the Earth in the form of beams. Now, specifically microwave radiations are here because only visible light, microwaves and radio waves can cross the atmosphere of the Earth, and out of these radio waves are used for communication. And in this case, if energy transmission happens through radio waves, then there will be problems of interference in communication, and visible light scatters as soon as it enters the atmosphere. So, sending energy through this spectrum makes no sense, and that's why microwaves were chosen. The energy coming from the Dyson swarm will come to the Earth in the form of microwave radiations. After that, those radiations will be converted into different types of energy and used. The biggest advantage of this entire design is that if an asteroid collides with a solar panel, then only that solar panel will be destroyed, and not the entire structure. So, here you can see how a small change in Armstrong eliminated a major flaw in this Dyson sphere. But still, this is just putting the cart before the horse. Because before bringing energy from the Dyson swarm to the Earth, there will be a crucial step in how to make these 1 crore solar panels and send them into space. Where will we get the resources needed to make such a huge megastructure? So, when Armstrong calculated the mass of the materials needed to make the Dyson swarm, then he came to know that even though he is making a ring of those small satellites, still, to make it, it will take almost the same amount of materials to make the Dyson sphere. And if we need so much materials, then we will have to extract the materials from Mercury and Mars. And for this, we will have to develop the construction setup of the solar panels on both these planets. Also, after building the panels there, to directly launch them towards the sun, we will also have to set up a rocket launching station. Which means, in short, this whole process will only be possible for humans when we go and live on other planets for us. Because in that case, we will be able to establish the setups to make and launch the Dyson swarm. And many scientists say that to reach this level, it will take about 1,000 years for the human civilization, meaning, all in all, to make a modern megastructure like the Dyson sphere or Dyson swarm, and to squeeze the energy of the star with the help of it for us. For any alien civilization, it is very difficult. And because of this, most scientists believe that the Tabi star, which was seen dim in 2015, was most probably not because of a Dyson sphere, but because of a dust cloud which may be making it look dim. After all, something similar has happened with the Betelgeuse recently. In its case too, it was said in the beginning that it was getting dimmed unnaturally. But later it was found that behind its dimming, there was a big dust cloud which was covering it. But let's assume that somehow, in the future, we will be able to find out how much has been advanced. What then? Will it still be worth our efforts? Because, according to some scientists, we will need so much energy to extract material from Mercury that we will spend half the energy from the Sun. And in this work, if we add the energy to extract materials from Mars, then more energy from the Dyson swarm will be spent to make it. It happened the same way, as if someone is giving you 20,000 rupees, but to get it, you need 40,000 rupees. This just means that the efforts we are making in this whole process, the result we get in comparison to that, will be less profitable according to energy economics. But yes, it is also possible that we are calculating this energy economics on the basis of our current technological advancement. And further, with advancement, we will be able to make energy extraction exponentially more efficient.